Joyce has key attributes of FRP composites for infrastructure applications. I want to remind the audience that we are going to hold our questions, and after the four speakers, we're going to have a panel discussion. Those who are virtual attendees can use the question and answer feature to submit your questions, and we will present them to the speakers. Joe, it's all you. Thanks.
You want to bring up the first slide? Thank you, Roberto. It's a pleasure to be here and have the opportunity to speak to you about the attributes and benefits of FRP composites for infrastructure applications. I'm going to begin with my take-home message and then give it to you again at the end. And the take-home message is that there is an extremely good fit between FRP composites and our nation's infrastructure needs today and in the future. I strongly believe that to be the case. And the reason is because of the 5 key attributes that I've listed here on this slide. FRP composites are lightweight, easy to install, corrosion resistant, extremely durable, and resilient. In the next 10 minutes or so, I'm going to go through each of these attributes and also talk about the benefits that are a result of these attributes. And so let's begin going through these bubbles, and I'm going to do the first 2 together, lightweight and easy to install. So FRP composites are lightweight. As this graph here shows, FRP composites are lighter than steel, aluminum, concrete, and brick. The y-axis here is pounds per cubic foot, and FRP composites come in at about 100. The exact value will depend on the relative amounts of resin and fiber. CFRP composites are lighter than GFRP composites, and that's one of the reasons that carbon fiber composites are used in aircraft like the Boeing 787. If you look at the numbers, you'll see that FRP composites are about 1/5 the weight of steel. They are 40% lighter than aluminum and about 30% lighter than concrete. And this really translates into numerous benefits, including labor savings, improved worker safety, lower transportation costs, and the need for less equipment during installation. And I'm going to talk about all of these benefits in just a few minutes. So here are some examples of lightweight composites. You've already heard about the one at the top, the G-beam girders, but I want to emphasize here that these girders are 70% lighter than steel. The same is true for FRP rebar, which comes in many different sizes, and it is less than 1/3 the weight of steel. So 2 examples of lightweight composites. And I want to use these pictures to make an important distinction before I go any further. First of all, these FRP girders are made entirely out of FRP. The entire piece is a composite. On the other hand, FRP rebar is really a composite used to make a composite. FRP rebar is used as the reinforcement in a concrete matrix, and it makes that concrete matrix more durable and less prone to spalling and cracking. So an important distinction as we go forward. So the lightweight nature of composites really translates into easier or lower transportation and easier to install costs. And you've already heard a lot about the FRP girders, but I just want to emphasize here, again, the picture showing that you can put 16 of these FRP girders on a truck compared to 4 or 5 with steel. And you also need a less expensive crane to install the FRP girders. So with FRP, transportation and installation require less equipment, less energy, and less money. And I want to emphasize this here because ease of installation is an important consideration in the DOT's Everyday Counts or EDC grants. They are looking at ways to reduce costs, and it is an important consideration, and FRP composites meet that requirement for lower installation and transportation costs. The DOT is really looking for these grants for technologies that are proven but underutilized. And if you look at what the panelists are talking about and the speakers in the remainder of today, that's really what we're talking about, proven but underutilized technologies. Here's another example of the need for less equipment with FRP composites. This is a building example. This is a picture of the Terminal Tower in Cleveland. It's a famous landmark building, and it was renovated about a decade ago. And the cornices and the columns at the top of the Terminal Tower were made with FRP. And those columns were transported to the top of the tower in an elevator, not with a crane. So another example of ease of installation with FRP. The lightweight nature of FRP can also translate into labor savings and improved worker safety. These are two slides taken from a presentation by Brett McMahon from Miller and Long at the 2019 CAMEX show, which is ACMA's big annual trade show. Miller and Long is the largest concrete contractor in Washington, D.C. So they use a lot of FRP rebar. Now, in this particular talk, McMahon is talking about the use of FRP in buildings, but his comments really translate over into other applications, including infrastructure. He says here, for example, that FRP has the potential to significantly reduce labor costs. He says here that rodman is a hard, dirty job. And he pointed out that the use of FRP rebar on a job site makes it much safer for the workers. Those same points were echoed in this presentation by Owens Corning, which is one of the largest suppliers of FRP rebar, again, emphasizing labor savings and improved worker safety. On this slide, I want to talk a little bit about pedestrian bridges, walkways, and bike path. John showed a couple of examples here, but FRP composites can be used to make pedestrian bridges that are lightweight and durable. And here are examples from Ohio and Lake Tahoe. Again, echoing what John said, FRP can also be used to add a pedestrian walkway or a bike path to an existing bridge. And this is an important point also, because as the DOT deploys money from the infrastructure bill, they are looking for this. They want pedestrian walkways and bike paths to be added to bridges. And here are some examples where that has been done, these cantilever sidewalks. What you've got here are examples where FRP is enabling the lightweight addition to an existing structure. Lightweight addition to an existing structure. And Victoria Sheehan actually last night mentioned that in her talk when she talked about a historic bridge where they needed a new deck, but they could not add a lot of new weight to the bridge. So lightweight addition to an existing structure is a very big benefit of using FRP. So let's say a little bit more about that. And let's look to the future. What I'm showing here is a slide from a presentation, an ASC webinar on ASC's Future World Vision that was given by Jerry Buckwalter of ASCE. If you haven't seen this Future World Vision, Google it, because it is a really fascinating topic. And what I'm showing you here is a timeline for 5 different scenarios for cities of the future. In the interest of time, I'm only going to talk about the first one. I'm going to talk about megacities, which really aren't the future. They're already happening now. So in megacities of the future, urban air mobility is going to become a very important form of transportation. You're going to see many more eVTOLs and drones in a city. And it's very likely that those aircraft are going to be made out of composite for the same reason that a Boeing 787 is made out of composite. But from an infrastructure perspective, those aircraft, whether they're manned or unmanned, are going to need a place to land. And FRP composites would be ideal for putting heliports and vertiports on existing buildings or existing parking garages. And here is another very good example of lightweight addition to an existing structure. Here's another look into the future. This is a picture from an article about Future World Vision in Civil Engineering magazine. And this caption's a little bit hard to read, so I'm going to read it for you. Modular construction may be made faster and more efficient by shop fabricated pieces delivered to job sites by drones. The instant I saw this picture, the first thing I thought about was the FRP girders, the G-beam girders, because those girders are 70% lighter than steel girders. And it would be much easier for a drone to transport them to a job site. So another very, very good example of lightweight addition to an existing structure. It's happening now, and it could be a very important part of the future. Let's move on to corrosion resistance. FRP composites are extremely corrosion resistant, and they are used in a wide variety of industrial applications where corrosion resistance is important. They're used in the chemical industry. They're used in the mining industry. They're used to line the stacks at these power plants. And they are used in all kinds of pipes and tanks and ductworks and liners and cladding in all shapes and sizes. So FRP composites are corrosion resistant. So is FRP rebar, much more corrosion resistant than steel rebar. This is a picture of a display, an ACMA display at the International Bridge Conference. And John likes to call it the iced tea slide. Okay? It's a little bit hard to see here, but what you have is a jar with a piece of FRP rebar sitting in salt water, and the water is clear and colorless. On the right-hand side, you have a jar with a piece of steel rebar. And after only 52 hours, it has taken on the appearance of iced tea because of the corrosion that has occurred. This makes FRP rebar ideal for use in chloride-containing environments where there's seawater around or where there are de-icing chemicals that are used to remove the snow on icy roads and bridges. So how have people taken advantage of the corrosion resistance of FRP composites? Well, the state of Florida has been a leader in the use of FRP composites and FRP rebar reinforced concrete. They've used it in bridges and seawalls and piles and piers and culverts and sewers. And they've published a lot of information about their use of FRP on their website. FDOT has also contributed to one of the most comprehensive LCAs and LCCAs for the use of composites in infrastructure. This is an article from Advances in Civil Engineering Materials. The primary authors are Thomas Cadenazzi, Tony Nanni, who is a professor of civil engineering at the University of Miami, and Steve Nolan from the Florida Department of Transportation. They have conducted a life cycle analysis, LCA, and LCCA, life cycle cost analysis of the Halls River Bridge, which is located north of Tampa, and this project was completed in 2019. They have used all kinds of FRP elements in this bridge, and I could spend an hour just talking about this life cycle analysis paper, but here's the Cliff Notes version. Their LCA showed that carbon dioxide emissions were 26% lower with FRP than with steel. And their LCCA showed that the net present value of the life cycle cost is 20% lower with FRP than with steel, primarily because you do not need any corrosion protection steps during the lifetime of the bridge. And the bridge is designed to last for 100 years compared to 75 years for steel. Let's move on to durability. FRP composites are extremely durable. They are used in a wide variety of industries. And I'm using these pictures to show you that things like airplanes and windmill turbine blades and underground storage tanks and truck hoods and John Deere tractors are built to last for decades. And they do, because FRP composites are extremely durable. Just think about how long boats last. So let's stay on the water theme for just a second. I've talked about corrosion resistance and durability in seawater. Let's just talk about resistance to water in general, durability in water. FRP composites are extremely resistant to water, which makes them ideal for a series of waterfront and coastal applications. They are used in pilings and piers, pilings and fenders at piers. You've seen some of these pictures with bridge protection. They're used for these protective dolphins at this ferry landing. And these locks here are an example of FRP in an inland waterway. Water resistance is a very important attribute of FRP composites. And we heard about a flood in Maine last night. FRP would be very resistant to that water. We've heard about flooding in eastern Kentucky. We've even had flooding recently in Death Valley. So let's finish up with resiliency. Talking about flooding is a good segue into resiliency. I define resiliency as the ability to withstand and to bounce back from natural disasters and extreme events. And with that definition, FRP composites are extremely resilient because they are resistant to damage from hurricanes and the resultant storm surge, tornadoes, earthquakes, and fires. This is a picture of a seawall that has been built in New York after Hurricane Sandy. And this is a picture of a dune restoration project that was completed in Florida after Hurricane Matthew. FRP composites can also be used in place of wood to make utility poles that are more resilient. FRP can be used in the vertical poles or in the cross arms. Now this picture here is the aftermath of a hurricane. And you have to take my word for it because there are multiple poles in this picture, but this is the only composite pole. And it is the only one that survived the hurricane. And as this headline shows, composite utility poles can also survive forest fires. And we've seen a lot of those this year as well. That's accomplished by selecting resins and additives that make the FRP more fire resistant. So in closing, I've talked about these 5 different attributes. Now I want to summarize the benefits that come from these attributes. You've heard me say that FRP composites are lightweight and easy to install. And that translates into these benefits: labor savings, material savings, equipment savings, time savings, and improved worker safety. The corrosion resistance, the durability, and the resiliency of composites translates into lower maintenance costs and lower replacement costs. And if you add up all those benefits, it translates into lower life cycle costs, which Ed is going to talk about in just a few minutes. So I'm going to finish where I started with my take-home message that there is an extremely good fit between FR composites and our nation's infrastructure needs, both today and in the future. The infrastructure bill commits money to all 17 categories of the ASCE's infrastructure report card. And FRP composites can be a solution in many of those categories right now. And I've also shown you some examples where FRP composites fit very nicely into the infrastructure of the future. So with that, I'll conclude my presentation. I'd like to thank you for your attention, and I'll be happy to answer any questions after all the panelists have presented.